So in the first paragraph containing question number 15 and 16, for the system shown in figure, friction at all the surfaces is absent, pulleys are massless, mass of wedge is 2m and that of block is m, a horizontal force F is equal to mg is applied on the system as shown. Based on information given in the paragraph, answer the following question at the given instant. So in question number 15, we have to calculate normal reaction between wedge and the block. That is the normal reaction between wedge and block. And the second is acceleration of the wedge. So let we assume the acceleration of this wedge is a in the horizontal direction. So if I draw the free body diagram at this instant, then tension T is acting in this direction, T is acting in this direction, T is acting in this direction, and T is acting in this direction. So if I resolve the forces, then this angle is 53, so this angle is also 53. So if I take the component of this tension in horizontal direction, then the component will be T cos 53 degree, and in vertical the component will be T sin 53 degree. Since the pulley is massless, so if I apply F equal to ma for the pulley, then I can say that F is equal to mg, and that is equal to T plus T cos 53 degree, and the value of cos 53 degree is 3 by 5. So if I solve for T, the value of T comes out to be 5 mg by 8. This is my equation 1. If I write the free body diagram for the wedge, then for the wedge we can see that this is my wedge and this is the pulley. So tension T is acting in this direction. So the component of this tension T in this direction is T cos 53 degree. Similarly, the component of this tension in this direction is T cos 37 degree. So if I take the component of the normal, which is acting in this direction, and if I take the horizontal component, since this angle is 37 degree, this angle is also 37 degree, so the component in this direction comes out to be n sin 37 degree. So with respect to inertial frame, if this wedge is moving in this direction with acceleration a and the mass of the wedge is 2m, then we can apply F equal to ma on this. Then I can write n sin 37 degree, that is 3 by 5, plus T cos 53 degree, that is T into 3 by 5, minus T cos 37 degree, that is T into 4 by 5, and that is equal to mass, that is 2m, into acceleration a. So if I solve this equation, we will get 3n plus 4t is equal to 10 ma. This is my equation 2. Similarly, if I write the equation for the block of mass m, and if I write the equation with respect to this wedge frame, then I have to apply a pseudo force on this block m. So the pseudo force will act in this direction, m into a. Since this angle is 37 degree, so the component of ma in this direction will be ma sin 37 degree, and normal is acting in this direction, and the component of mg in this direction will be mg cos 37 degree. So with respect to this observer, which is in the non-inertial frame, the block is moving along this line. So I can say that the component of the force perpendicular to the plane are balanced. So the component of the forces perpendicular to the plane are balanced. So I can write n plus ma sin 37 degree, that is 3 by 5, is equal to mg cos 37 degree, that is 4 by 5. So this is my equation 3. So on solving equation 1, 2 and 3, we will get the value of n and a. On solving equation 1, 2 and 3, we will get the value of n and a. The value of n comes out to be 65 mg by 118, and the value of a comes out to be 49 g by 118. So let's check the options. So the correct answer for question number 15 is option D, and the correct answer for question number 16 again is option D. So the correct answer for question number 15 is D, and for 16 is D. Let's move to the second paragraph containing question number 17 and 18. In the paragraph 2 containing question number 17 and 18, it is given that a river of width D is flowing with velocity v0. A swimmer standing on one bank of river at A is capable of swimming with velocity v0 in still water. Swimmer swims always heading towards a fixed point B, located opposite to point A. It can be further proved that swimmer is always equidistant from point B and line x equal to D. So in question number 17, we have to find out trajectory followed by swimmer with respect to observer on ground, and in question number 18, we have to calculate the drift of swimmer when he is about to reach the other bank of river. So in the given question, there is a catch, and here it is given that swimmer is always equidistant from point B and line x equal to D. So this is the condition of parabola in which a point lying on the parabola has an equal distance from the focus and the directrix. So the correct answer for question number 17, that is the trajectory followed by swimmer with respect to observer on ground, is parabolic. So option B is the correct answer. And in question number 18, if suppose this is my x equal to D and the swimmer reaches to this point on the opposite bank of the river, then from the condition of parabola, I can say that the distance of the swimmer from B, this distance, must be equal to the distance of the swimmer from the line x equal to D. So if this distance is suppose x dash, then 2x dash must be equal to D. So x dash is equal to D by 2. So the correct answer for question number 18 is also B. Now the question is, if we want to calculate the equation of the trajectory on which the swimmer is moving with respect to the observer on the ground, then suppose let B is my point of origin, and suppose this axis I have considered my y-axis, and this axis I have considered as my x-axis. So at t equal to 0, swimmer is at this position, and let the swimmer is moving in this path, and at any time t, the swimmer has reached to this position. So when the swimmer has reached to this position, it is always heading towards point B. The swimmer is like this, and the velocity of the river at that moment is v0 in this direction, and the velocity of the swimmer in still water is v0 in this direction. Let at this moment this radial vector makes an angle theta, and the distance of the swimmer from point B is let r. So if I take this angle as theta, then if I extend this, then the angle from the vertical is also theta, and the component of the v0 in this direction is v0 sine theta, and the component in this direction, that is v0 cos theta. So if I write minus dr by dt, rate of change of distance of swimmer with respect to point B, is equal to v0 minus v0 sine theta. This is my equation 1. And second equation I can write d theta by dt, that is the angular velocity, is equal to v perpendicular, that is v0 cos theta divided by r. So if I divide these two equations, then I can get minus dr by d theta is equal to r into 1 minus sine theta divided by cos theta. So if I further solve this equation, then I will get minus dr by r is equal to sec theta minus tan theta into d theta. So if I integrate this, at theta is equal to 0, when the swimmer is at x equal to a, the value of r is equal to d, and at an angle theta, the value of r is r. So if I integrate this, it will give me ln d by r, and since the angle theta is acute because it lies between 0 to 90, integration of sec theta will give me ln mod of sec theta plus tan theta. Since theta is acute, so I can write ln sec theta plus tan theta minus ln sec theta on applying upper limit and lower limit. So on further solving, I can write d by r is equal to sec theta plus tan theta divided by sec theta. So on further solving, I can write d by r is equal to 1 plus sin theta, which can be further written as d is equal to r plus r sin theta. Now, if I want to write this equation in Cartesian coordinates, then at time t, when the swimmer is reached to this position, let the coordinate of this point is x comma y. X coordinate is x and y coordinate is y. So I can say that then the x coordinate will be r cos theta as per my chosen frame of reference, and y coordinate is r sin theta. And here r sin theta is equal to y. So I can write d minus y is equal to r. So on squaring, I will get d square minus 2dy plus y square is equal to r square. And from here, we can get r square is equal to x square plus y square. So y square get cancelled out. So from here, I am getting x square is equal to d square minus 2dy. So this is the equation of parabola. So the correct answer for question number 17 is option B. And in question number 18, drift of swimmer when he is about to reach the other bank of river. So at the moment when the swimmer reaches to the other bank of river, then the x coordinate becomes 0. So on substituting x coordinate becomes 0, the value of y coordinate comes out to be d by 2. That is the drift of swimmer. So the correct answer for question number 17 is option B. And for question number 18, again it is option B. By this, I wish you all the best for your preparation. Have a good luck. Thank you.